Alright, this is my project for CS6530. This is a provenance tracker and heat map constructor. So the first thing we would usually do is run our first method. I can pull this over here too. It is this query driver. You would usually run this from the command line. And what this does is take your query file that we've made. This is tailored to the IMDb dataset, but it's pretty schema agnostic, so you could probably do any sort of database as long as you change the queries to be correct and you change your database to be correct. So this is just pretty simple stuff. Select count, order by, things like that. So we're not going to do that step because it takes a while. But what that does is once you run it, you get this this log JSON. And so what this is essentially this project. It goes through your query list and it will compile this log file, and it'll get all of your all this metadata sort of from the queries, like which tables hit, which query it comes from. And so really the heart of the project is when we do something like this, where we run our heat map from log file in our source folder, and we use this log file that we're using, and we also use this base tables helper. This just helps us be able to make it a little more agnostic because we're using the IMDb database. You can see up here we made this from SQLite, but in theory this should work for all sorts of different databases. But we will demonstrate it now. We run this heat maps and we get this pop-up that has our tables on the side, it has our queries on the bottom, and we can see how many queries were in, or how many counts. So query 1 had a lot, hit titles a lot. Query 4 hit ratings a decent amount, but not quite as much. And then if we X out of this, the next one that pops up is the time usage. So we can see from here that query 9 is enormous, but most of the rest of them aren't so bad. And it's interesting that these share all of the tables except for this one, except for this ratings right here. So that's an odd thing that you might look at that and think, okay, maybe ratings is put together pretty poorly. Maybe the actual query itself of query 9 is pretty inefficient. But this just allows you to have some sort of insight into the way your database and queries are working. So that's the heat map. We can also run our provenance graph, or prov graph from log Python file, same parameters, and this time it will give us a provenance graph that's which queries are going to which tables, right? So we can see query 9 does a lot of things. It hits a lot of different tables. We can also see a lot of queries hit titles, right? And we can see query 1 does a lot of them. Probably because all query 1 does is read titles, but then we can also see 7, 8, 9 all hit titles. 4, 7, and 9 hit ratings. So this can give us a little bit of insight on where to build indexes or where to make materialized views. And you probably don't want to make a view or an index on AKAS because it's only query 6. But for some of these that have a lot of different branches coming out, you might want to consider doing an index. And you can see some of these have common factors, you might say, so you could consider doing a hybrid or combined index on those. But that's pretty much all there is to it. It's a command line interface, and the project report itself goes a lot more in depth on how it works.